I work in the systems assessment group at AWE, and I'm going to talk a little bit about some software tests that I managed to automate using Python scripts. So I'm going to go for a bit of background on automation itself, although I'm not sure if people need it too much. I'm going to talk a bit about the motivation behind the actual bit of work, talk about the program that was automated, and also the tool itself that I wrote to automate it. Then I'll step through the different sort of main parts of that tool, and then talk a little bit about the benefits that we've seen so far and about some potential future applications that could be realized. So, as people probably know, automation is generally used to increase the efficiency of doing something. This can be used in lots of different applications. You can quite often do this by taking a repetitive or tedious task and making a computer do that instead of, and removing the human involvement in that. You can see some examples of that in something like a self-service checkout at a supermarket, with the automated manufacture in different industrial workflows. You can also see it in quite often employee reviews are sort of scanned and analysed before anyone actually goes through and looks at it. And on the more complicated end of the spectrum, you do have things like self-driving cars, which are coming into sort of being built now. But this can also be sort of useful for specific tasks if you think you're going to be repeating them in the future. So the program itself that we're trying to automate is a program written by the systems assessment group. It's actually a fast running weapons code, so we use it to model blast wave propagation. The inputs are all set up using a few XML files which will specify one of, or a few of, a large number of possible inputs depending on the actual scenario that you're looking at. These quite often each have nonlinear effects in of themselves, and then the output is going to be a 2D heat map of probabilities that can then be analysed and looked at. So the motivation for this was a trend analysis task, so we wanted to run this program with a large variety of inputs which covered the test space, and actually see how the trends varied with the different inputs and see if they were doing as we expected. So in the past, this has taken sort of in the order of weeks, and this was mainly due to the manual work that was required to set up the different combinations of inputs and actually analyse these results themselves. This quite often occurs due to the sort of the number of changes that you have to make per input and actually the specificity in the variables and how they have to be ordered in the XML files. So to tackle this, I wrote a tool in Python which uses a command line interface. By that I mean it's actually a function that you can run in Python. So if you do the interactive environment, you could then run it from the command line. But it will use a simple CSV input which will have multiple scenarios inside it and then generate all of the required inputs that you would normally make yourself. It can then run the program itself and monitor the progress of the program throughout. And then once this is done, it will plot all the results in a format that you define, and then collate all of these inputs that you used and the results that match up to them, and then publish these in a simple PDF report using LaTeX. And yeah, this is all done from a single CSV input instead of loads and loads of XML ones. So this is just a rough overview of how the tool itself wraps around the main sort of program with the CSV input at the top and the user interface, and then all of the 4 separate parts that essentially work in a linear fashion to then get you some report of results at the end. So I'll go into a few of those now. So the input generator, as I said before, all of the inputs are specified in a single CSV file. You can specify loads of scenarios in a single CSV file with each row corresponding to a single one. We then use pandas to read in the CSV file as a data frame object, which can then be iterated over. And then once this has been read in, it also creates a resource folder which all of the standard inputs will later be put into. This resource folder will match the input name. So then, as I said before, the XML files are generated using these inputs from the CSV file. This is done using the elementary package in Python. to basically go through the CSV file. Each row will be an input and then put them in the correct order, sort of as an example on the left-hand side, which is completely arbitrary. You can sort of see that it would then put it in that kind of format. These are then stored in their own scenario folder, which is inside the resource folder. So you'll have lots of scenarios inside a single resource folder, which comes from a single input file. In addition to that, since the actual input types vary quite strongly depending on the scenarios you're looking at, there is an options file which isn't created by the user. This is just set inside the program, or the tool itself, sorry. And this will specify the inputs that are required, the type of input that it actually is. So as you see at the top there, there's strings, floats, integers, or others. And then it will also specify the order in which it needs to appear in the XML file, since the program itself will only run it if these are in the correct order. This also allows you to completely skip over any additional inputs that the user adds that aren't needed. And also, if you are missing an input in the CSV file, it will tell you which one it's missing, just so you can sort of go back and make sure you've got that one. An additional thing as well is that the tool itself will check the previous inputs or the previous XML inputs to this one, and if any changes are noticed, it can delete the results for you so that you are always using the most up-to-date results, and you're not going to think that the program's run and then actually end up finding out you're running something from a previous input. So the program runner itself, so the program has a batch mode. This can be run from the command line as well. So we use the popen function in Python to basically pass this command line argument in with the required inputs, which would be the resource folder that now contains all of the inputs. The program itself will then just run across all of these and spit out a results file inside those folders for each of the scenarios. Unfortunately, the program doesn't actually automatically close by itself because it was designed to stay open so that the user of the batch runner could tell that the program itself had finished and it hadn't just closed for a different reason. Because of this, the progress of this is then checked in Python to ensure that all of the results files have been generated. And once they have, it will then kill this process and close the process itself so that the batch runner is not just sitting in the background. So once the results are all done, then it will automatically find all of the results and make sure that it does the correct plots for each of these results. As it knows the folder structure, it will go into the specific place that it expects it to be, and it will try and make the plot. If there's not one there, it'll skip over it, but give you a warning that there is no results there, so you aren't also missing things that you think you should have. So these are all then spat out into an outputs folder inside the resource folder, in which you will have just a list of all of the plots for each of the scenarios that you would expect. These plots can also be specified to be a different type as well. So I mentioned the 2D heat map previously. You can also have a slice of this if you expect it to be symmetrical. Or you could even plot a single, or have a single plot for all of the scenarios in the 2D space, so you can compare the different lines themselves. And the final bit is the LaTeX generator. So to quickly get an output from this, a standardized sort of report is automatically made at the end. This just uses text files, so the strings are modified to contain the specific figures and the specific tables for that given scenario. So they all use standard formats, meaning that it can take any of the images that you would expect and just put them in the correct layout. And also the tables can be automatically adjusted depending on how many inputs you actually have for that scenario. So you don't have to specify the width or anything. It will do that automatically and then just pull all of the environments file or the inputs and put them into their own table. You can also use multiple CSV inputs or a single one to combine them into a more structured format document using a template. So on on your side, right-hand side, there is just a simple example of what a template could look like, in which you have specific fields for, say, the title, the author, and where the actual sections are going to go themselves. It will then fill this with the given fields that you will input when you run this function, and it will return a full report with the given sections for each of the inputs. What I got here. So you can also have additional options in there, so you can include an introduction for each of the sections if you pass a specific text file to it. This can include references, and that will all be set up so that it uses BibTeX to give you specific references in there as well. And actually, to run it itself, the top one just shows the if you just want a single PDF output and you want to do all of it, then you just run the single function main there, and it will sort everything else out itself. You can specify to run different parts of it, so if you only want to generate the inputs and also run the program, then you can do that by just setting those to true and putting the plot and the PDF functionality to false. Alternatively, you could do it vice versa. So if you've already ran it once and you don't want to do it again, you could just turn XML and run to false and then only remake the plots and the PDF. And the bottom bit is just showing how you would then combine pre-rendered sections and turn them into a full section or a full report with a given template. So far we've seen a few benefits from this. So as I said before, the previous trend analysis took several weeks to actually complete. When using this tool, you can complete it a lot quicker. So the latest time we did this, it actually only took about a day to fill in this CSV input. And then you could send it off and run it overnight as well if you wanted. So it was completely automated, so you didn't have to go in and sort anything out afterwards. You just have to populate that CSV. So you can also rerun previous inputs if you want. This allows you to check for regression testing as well. So if anything's suddenly changed in one of your PDF outputs, you can quickly identify it by comparing the reports themselves. It's also been used for different tasks other than trend analysis as well. So there was a sort of, not quite an optimization study, but a rough kind of task that we had to perform afterwards as well. And we used this to quickly run multiple scenarios by varying just one of the inputs to a range of values to find the one that gave us the correct output. So it was quite easy with that. And in addition to that, other people have been able to use the tool as well. I've helped other colleagues of mine run the tool, even though they have fairly limited Python knowledge as well, as it's basically just populating an input file and running a function. So that's helped other people perform their task a bit quicker as well. And there are the possible future potential. You could remove the user part at the beginning with the CSV input and get the write a new script to automatically vary the inputs itself. This could even be used to make it find a specific value in an output as well, so you could optimize the inputs to find a desired output if you wished. The LaTeX Generator is quite sort of, I guess, rudimentary in a sense, so it could be modified to work with a variety of other programs if you needed just a standardized report format, just to quickly show results. You could also use the tool to quickly populate a lot of results and then just send them off and leave it be. And then you could use those results to maybe train a machine learning program, which could then in part replace parts of the original program as you've already found the relation. And that could eventually speed up different aspects of the program itself. But yeah, I think that's it. Sorry if I ran through that a bit quick. But thanks for listening. Any questions?